So we'll start with the discussion of Unit 6, which is October 2021 paper. We'll do some questions, like question 1 and 2 today, likely. And the second part, we'll discuss one question from Unit 5 for a revision, and then at the end, we'll do explanation of Unit 4. So the question 1, a wire wound resistor can become hot when there's a current. And this heating effect can be investigated using an apparatus as shown. So as you can see this apparatus, we can use this heating effect. Like we can use this current and the heating effect to investigate the apparatus is there as shown. A student investigated whether the temperature rise of a water was proportional to I in the resistor. Like he's finding if he like whether two quantities are directly proportional. If we are increasing one, other also increase with the same factor. That's what he's investigating. For each current value, the student refilled the beaker with the water at the same initial temperature. Identify two other control variables for this investigation. So if the student want, like he's investigating, if he want the fair comparison, then what every time he refill the container with the water, so the volume of the water should be same. And the second thing is, as you can see here, the distance between the resistor and the thermometer should also be same. These are the two main factors which should be same. So the volume of the water and the distance between heater and thermometer. So these are the two factors that should be same for a fair comparison for comparing the two values. The student record the following data. As you can see, student changes the current and the theta is there. Criticize the recording of this data. First thing, how you criticize the results. As you can see, there is no repetition. Like student changed the current 1.5, but he did not repeat any value. Like so, there is no repeats are there as shown. And another thing, is directly student measure the like he calculated this is a data which he record. He directly entered the change in temperature, because for accuracy what he should do, as the student is investigating the heating effect, so he should measure the initial temperature and he should measure the final temperature, and then he will take a difference to work out the temperature change. But in this case what happened, student is directly measuring a temperature change, because temperature change is something which we should calculate, and we should measure the initial and the final temperature. And what else is missing? You can see there is no column heading for the temperature change. The units are missing here, whether it is in Kelvin or Celsius, that is also missing. So the criticism on this reading, that there is no repetitions. And the second thing is, student did not measure initial and final temperatures are missing. And there is no unit for temperature change in the table. So the no unit for the temperature change. So these are the points which are missing. No repeats, initial and final temperature are missing, and no units for the temperature change. Like he did not write any unit here. Or you can also say small range is there, because just measuring for 1.5 to 3, that's a small range of a data. If you try to plot a graph like from 1.5 to 3 or 3.5 to 15, that's a very small range for plotting a graph. That's why it won't be accurate as well. Like you cannot recognize the trends. Inconsistent significant figure, yes, you can say that as well. As here, two significant figure, one significant, then two significant, then two significant. So inconsistent significant figure, that is also you can criticize the results, as it was there in AS as well when we criticize the results. Explain one improvement the student could make to reduce the uncertainty in the measurement of a temperature change for each value of I. So how we can reduce the uncertainty? When we are measuring a temperature change, one improvement that stood, so improvement to this apparatus, what stood, because as you can see, there is no insulation is used here. No lagging or insulation is used. So students should use lagging or insulation, and the student should use a lid on the top. So if there's a lagging insulation surrounding lid at the top and there is a mat, the insulating mat is there at the bottom, then we'll have a much accurate result as compared to what student is getting now. So one improvement the student could make to reduce uncertainty in the temperature change. So student should use lagging or insulation or a lid, and that will reduce how it will work, how it will be effective. It will minimize the heat loss. So use lagging or a lid or insulation, and how it will be effective. It will minimize the heat loss to the surrounding. So smaller amount of energy will be lost to the surrounding. Moving on to question 2. It's related to a pendulum of length L swing in a vertical plane. The string hits a peg placed at a distance h. You can see here the peg is placed at a distance h at the point of ascension. This make a pendulum shorter for a part of its motion. Like the pendulum is vibrating here. When it hits the peg, now this is a length which has changed. Determine the time and period t for a whole oscillation where when h is 0.35 and L the length is 1 meter. So how we can determine the time period? The height is given, the length is also given. The formula which we use to calculate the time period t is equals to 2 pi under root L over G. This is a formula. To calculate the time period of oscillation of a simple pendulum, it is 2 pi t is equals to 2 pi under root L divided by G. But we have a longer pendulum, like this one is a longer pendulum and this one is a shorter pendulum. So we will work out the time period for a longer pendulum and for a shorter pendulum, and then we'll take an average, because as the time period will change. So first we'll use the formula t equals 2 pi under root L divided by G. That is for the long pendulum. And then for a short pendulum, we use the same formula t is equals to 2 pi under root L divided by G, and then we'll take an average. So when we substitute the values, so the first one will be 2 pi under the length is 1 meter and the acceleration due to gravity or gravity is 9.8. So when we substitute these values, like under root 1 divided by 9.8 into 2 into 3.14, so this will give us 2.01 seconds. For a shorter pendulum, we'll also use the same. So 2 pi under root L divided by G. So it will be 2 into 3.14 into under root, the length is there, which is, because look, what about the length of this pendulum? If this length is 1 meter and here is 0.25. So length of the pendulum is a length like the distance from the point of suspension to the center of the mass. So this here is the center of mass, and now this is the point of suspension where it hits the peg. So this will be the length. So 1 minus 0.25. So we get 0.75 meters. So this length will be 0.75 divided by 9.81. So this will give us the time period. That will be 1.74. But we have to determine the total time period of this combined pendulum, which is a longer plus shorter. So we'll take an average as two results are there. So 1.74, 2.01 divided by 2. So this will give us 1.88 seconds. So that is the time period of this pendulum, which is initially longer. As it hits the peg, it get short. Is it clear, this one? Okay. The next is, after finding the time period, the next part, a student suggested that an approximate relation between the t and the h is given by a formula that t square is equals to pi square over g bracket 2l minus h. Devise a plan to test the validity of this relation using a graphical method. Include the use of a stopwatch and any additional apparatus as required. So what we have to do, this is a 6-mark question, which is showing a high weightage. So we have to state the method, how it should be done, and then we will use this equation to work out what are the quantities we should measure. So, and how it can be measured. So both we have to mention. So if you want to check the validity of this result, like we have this t square is equals to pi square over g2l minus h. So how this experiment should be done? The heights will, like, we'll measure the length of a pendulum and the height of the peg from the position point of suspension by using a meter rule. So we can measure L and H by a meter rule or a meter scale. So the heights, we will use the meter scale or a meter rule to measure the heights, length as well as the edge. Then what we'll do, like we will move this pendulum to extreme position, and usually a small angle it should be moved, because if you make a larger angle, then this formula t is equals to 2 pi under root L over G is not valid. So it is very important that you mention it displace the pendulum. So what we'll do, we'll displace the pendulum to very short distance or to a small angle, then start the timer, record time for 20 oscillations, and after recording a time for 20 oscillation, to get the time period, so time period is divide the time recorded by number of oscillation. And then repeat, take average. And because here we are changing, the height is there, h is there, then repeat experiment with different, usually you cannot mention like just repeat experiment. How many times? Minimum, you should repeat the experiment 3 times. So repeat experiment So best way is just repeat the experiment 5 times with different heights. So this is a procedure of this plan. Like first we measure the length and the height by using a meter rule. Then we displace the pendulum to a small angle and we record the time for 20 oscillation. Then divide the time recorded by number of oscillation and then repeat the method at least 5 values of h. Now what graph we should plot? Because we have this equation. So if I simplify this equation, it will be t square is equals to pi square g 2l minus pi square g over h, because this pi square g is multiplied with both of them. If I rearrange this equation, so it will be t square is equals to minus pi square over g into h plus pi square g into 2l. Now, when we compare with the equation of straight line, so y is equals to mx plus c. So on y-axis, if we plot, so we have to devise a plan to test the validity of a relation. So what graphical method? So we'll plot a graph for t square on y-axis and h on x-axis. So what will the gradient? The gradient will be equals to minus pi square over g. Pi is constant, g is constant, so it will be a straight line with a negative gradient. So what will the shape of this graph? So it will appear like this. So this will be the shape of the graph, that it will be a constant gradient and it will be negative gradient, no, negative constant gradient. So that's how you score the 6 marks. Is it clear how we plan this experiment and how we sketch the results? Any doubt in this? Why the pendulum should be displaced at a shorter angle? Because this formula, the initial formula which we use to work out the time period t is equals to 2 pi under root L over G. This is devised on the limitation or the condition that the theta is very small. So theta is approximately equals to sine theta. So sine theta and theta are equal when the theta is very small. That's why this relation is only hold when the theta is very small. That's why it's important that you mention that we displace the pendulum to a very smaller angle. Otherwise, this relation won't be accurate. Like it won't last. It will not follow that. Another student suggests determining the t by setting up a light gauge attached to a data logger. Discuss whether this modification would improve the investigation. It's of 3 marks. So look, what is the advantage of using a light gate over a stopwatch? Because when we are using a stopwatch, there is a reaction time. But when we use a light gate, the light gate eliminates the reaction time. And also it eliminates the parallax error, like the wrong position of an eye. So if you're using a light gate, it will eliminate the reaction time and it will also remove the parallax error. But there's also one limitation with the light gates, because when we are using the light gates, light gates will determine the time period for a whole pendulum bob to move rather than the center. Because what will happen if we have these light gates are there? So when this pendulum will move, vibrate, the moment it and block the light, the timer will start, and then when it moves out, the timer will stop. So light gates are actually determining the time period of the whole pendulum to move. So light gates are giving us a time period for the whole pendulum to move rather than finding a time taken by a center of the pendulum to move. So usually, whenever we use a light gate, it will improve the results. It will remove the parallax error and the reaction time in the measured value. But one drawback of using a light gauge that would determine, like, there will be uncertainty in time period from the light gauge, as the light would, because the light gauge would time for the edge of a bob rather than the center of the mass. Like how much time the edge of the bobs is taking to move from one end to another rather than the center. That's why that is one limitation. Otherwise, it will be accurate. So this was question 2 from October 2021 paper.